Hey guys, in this video what I'm going to do is I'm going to recap atomic structure and bonding related to properties. Okay, this is the topic that tends to be the biggest, and it's the one that people find that they lose the most knowledge of over time. So they get it at the time, or they don't get it at the time, and then they lose that knowledge as time goes on. So they have to spend more time going over it. Okay, so let's fly through it. I do speak pretty fast in these videos. However, feel free to pause, rewatch, etc. Okay, so quickly about the periodic table, you know that elements are arranged in order of increasing atomic number. They start at helium. Helium? No, they don't. They start at hydrogen, number 1. Helium, 2. And then the atomic number goes up. You know that metals are here on the periodic table and non-metals are here. Simple as that. Okay. Groups are up and down on the periodic table, and they contain elements with the same number of outer electrons. So everything in group 1 will have 1 outer electron. Everything in group 2 are going to have 2 outer electrons. Okay. Within a group, elements have the same valency. If you think back to the formula topic, that's the number of bonds that an atom can make. That's what valency means. And similar chemical properties. So all the halogens react similarly. Fluorine, chlorine, bromine, iodine, all really similar. Noble gases. Helium, neon, argon, xenon, okay, all very similar, okay, because they have the same number of outer electrons. Electron arrangements can be found in page 6 of the data booklet. Remember that the first energy level holds 2 electrons, second energy level holds 8, third energy level holds 8, and then you don't need to know how many the fourth holds because it will only ever ask you up to element 20. So therefore, the biggest number you will see in the fourth one is 2. Okay, simple as that. Remember, it fills up from the bottom. So if it's got 5 electrons, it's going to go 1, 2, 3, 4, 5. So it'll be 2, 3. Okay, simple as that for electron arrangements. Okay, atoms make up everything. Okay, they have a nucleus, which is the dense, really dense bit of material in the middle that contains the neutrons and the protons. And they have the electrons that orbit around the nucleus. Protons, charge of 1 positive. Neutrons are neutral, that's why they're called neutrons. Electrons have a charge of 1 negative. Remember that protons and neutrons have a mass of 1, and we're going to use atomic mass units because they're so tiny that we had to make up a new unit to measure it in. So protons and neutrons have 1 atomic mass unit, and electrons have virtually no mass. Never say no mass. Always say almost no mass or virtually no mass, because they're still a particle. They still have a ridiculously tiny amount of mass. So you can't say they have no mass. Okay. The atomic number is the number of protons. So whenever on the periodic table, you will see that the atomic number above the element symbol, that is the number of protons in that atom. That means that, for example, carbon will always have 6 protons in its nucleus because its atomic number is 6. If it doesn't have 6 protons, it's not carbon. It's something else. Remember that in a neutral atom, the number of electrons is equal to the number of protons. That's because the charges cancel out. Okay, so you've got this 5. If you've got 5 protons, you will always have 5 electrons. 5 positive, 5 negative, cancel out. Remember, the mass number is the number of protons added to the number of neutrons. Remember, that's because those are the particles that have mass. Nuclide notation is as follows. You need to remember that. You need to remember the mass numbers at the top, the atomic numbers at the bottom, and the symbol is Na. Okay. Isotopes, very quickly. Isotopes have the same atomic number but different mass number. What that means is they have the same number of protons but different number of neutrons. Okay, so for example, these 3 carbon atoms all have a different mass number but the same number of protons, which means it's the neutrons that are different that gives them that extra mass. Okay, most elements have 2 or more isotopes. There's very rarely an element that only has 1 isotope. And the average atomic mass is calculated using the mass and proportion of each element present. So the mass, the relative atomic mass of carbon is 12. What that means is that the abundant isotope in carbon is carbon 12 because the relative atomic mass is closer to that isotope. If it was 13, you could say that this one that was my cursor, this one would be closer. And if it's 14, you would say this one would be more abundant. Okay, remember, whatever one the atomic mass is closest to is more abundant. If it's slap bang in the middle, then they're both as equally abundant, 50-50. Okay. On to bonding. Okay, so that was the atomic structure part. This is the bonding part. Remember that covalent bonding occurs between non-metal atoms. Only non-metals do covalent bonding. And these are held together because the two positive nuclei of each atom are both attracted to those negative electrons stuck in that covalent bond. So these atoms are technically trying to push themselves apart because they're both positive. However, they both like those electrons. They both want to have those electrons. So they're going to grab on, they're going to grab and be stuck in that covalent bond. Okay? Simple as that. Okay? So for example, hydrogen chloride. You've got your hydrogen here and your chlorine here. Chlorine already has 7 electrons. It only needs 1 to get a full outer shell of electrons. Hydrogen has 1 electron. It needs 1 to get a full outer shell because it's only its first energy level, so it only needs 2 to get a full outer shell. Okay. Covalent bonding. Last 2 things you need to know about covalent. Diatomics. Please remember your diatomics. However your teacher taught you how to remember them, use that. I'm not going to go over it because I don't want to confuse other people. If you weren't in my class, you won't have been taught the way that I teach how to remember them. So however you want to remember them, please do, but it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are the 7 diatomic elements. If you're writing down nitrogen in a chemical equation on its own, it's not just N, it's N2 because it bonds to itself. That's what the molecule is. Okay. Shape depends on the number of bonds. So if it's in the middle, you've got a carbon atom. Carbon can make 4 bonds. Therefore, if you have a carbon in the middle, it's going to form a tetrahedral shape. It's as simple as that. 3 bonds, nitrogen makes 3 bonds. So nitrogen would form a trigonal pyramidal shape, etc., etc. Okay. The only exception, linear, if you ignore this molecule here, that could be HCl, hydrogen chloride. The only exception is carbon dioxide, which is CO2. That's linear as well. Okay. Covalent molecular, that is when you have small molecules that have weak intermolecular forces, but strong covalent bonds in the middle of the molecule. It's these weak intermolecular forces between the molecule that gives it its properties. It's a low melting and boiling point, as you only need to break these weak forces to separate out the molecules when changing state. It doesn't conduct electricity because there's no charged particles able to move, and often insoluble in water, but can dissolve in other non-aqueous solvents. What that means is it can dissolve in other covalent liquids. Okay, covalent can dissolve in covalent. Covalent network, on the other hand, is basically just loads of atoms all bonded covalently. Covalent bonds are ridiculously strong, therefore covalent network has very high melting and boiling points. They do not conduct electricity because there's no charges able to move except for graphite, and they don't dissolve. Okay, so giant network structure where all atoms are joined by strong covalent bonds. Ions. Ions are when an atom loses or gains electrons. And they do that because they don't want a more stable electron arrangement is a full outer shell. So because the full outer shell is more stable, atoms will lose or gain electrons in order to get that full outer shell. Atoms lose electrons to form positive ions. Non-metal atoms gain electrons to form negative ions. That's because non-metal atoms tend to have 5, 6, 7 in their outer shell. So they would need to gain. It's easier to gain 3 than to lose 5 for boron, for example. Metal atoms tend to lose because they tend to have 1, 2, or 3 in their outer shell. So sodium 281. It's easier to lose that 1 electron than to gain a full 7 electrons. So that's why it's going to lose that electron. Electrons are positive, negative. So it's going to come overall positive. Okay. This table explains to you the charge. So group 1 will become positive, group 2 will become 2 positive, group 3 will be 3 positive, group 4 tends not to form ions. Funnily enough, it's pretty hard to lose 4 electrons or to gain 4 electrons, so it tends not to. Prefers covalent bonding. 5, 3 negative, 6, 2 negative, 7 negative. Okay, this is important because these ions can then go on and form ionic bonds. Ionic bonds are the electrostatic attraction between positive and negative ions. So, for example, this sodium atom is going to lose 1 electron. Where's it going to go? Someone else needs that electron. Funnily enough, it's chlorine. Chlorine's going to gain that electron. So sodium loses that electron to get full 8 in its outer shell. Chlorine needs an extra 1, so it's going to take that electron from sodium, and it's going to become 288. Sodium's now positive, chlorine's now negative. Opposites attract, they're stuck. Okay. These form lattice structures of oppositely charged ions with positive ions surrounded by negative ions, etc. Okay. These have very high melting and boiling points as well. Think about table salt. Yes, you can dissolve table salt, but have you ever tried to melt it? Doesn't work. You need to raise the temperature to stupid levels in order to melt salt. Okay. That's because the ionic bonds are strong and they need to be broken in order to break up the lattice. Many ionic compounds are soluble in water. This is because water is able to break down that lattice structure because the water molecules can surround the separated ions. Okay. Ionic compounds conduct electricity only when molten or in solution. This is because in order for something to conduct electricity, there needs to be charged particles able to move. In a solid, those ions aren't able to move. As soon as you melt it or dissolve it, the charged particles are now able to move, therefore it can now conduct electricity. Okay, that was a lot. I know that was a lot. Feel free to go back, pause, etc. Take your time to read the slide, listen to what I'm saying. Okay, this is a big topic. Feel free to ask. If I have any questions, I may just start a live call just so that I can answer any questions, because I know that people are going to have questions about atomic structure and bonding, but please do not be scared of asking questions. Okay, off you go now, do the mind map. If you get that done, then go do the past paper questions and I will see you on the Kahoot. Okay, thank you guys.